Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So today's video is a continuation of the previous video, that is binomial theorem. So I will cover the concept of factorials, permutations and combinations quickly before we jump on to the binomial theorem so that you will be able to tie up these two easily. So if you haven't watched my previous video, I will link it up here, but in that video I have covered the underlying concepts or the prerequisites that you need to note in order to understand binomial theorem. So I request you all to please watch that video before watching this video so that you will be able to tie up the concepts very easily. And so without wasting any more time, now let's jump right into the video. So what is a factorial? Just a quick recap on factorials. Factorial of a positive integer n means, first factorial is written as n factorial, or it can be written as factorial of n means the product of positive integers starting from n to 1. That means, what is 4 factorial? Product of integers starting from n to 1. What is 4 factorial here? N is 4, 3, 2, 1. So this is 4 factorial. 6 factorial in the same way is 6 into 5 into 4 into 3 into 2 into 1. So this is a factorial of a number. Factorial of any positive integer is a product of the positive integers from n to 1. Okay. There is an important property concerning factorials that you need to know. That is, n plus 1 factorial is n plus 1 into n factorial. What is this? Suppose, for example, n is 5. Okay. So here 5 plus 1 is 6 factorial. Substituting 5 in this equation, we get 6 into 5 factorial. And per the definition of factorial, what do you understand? You understand that factorial of any number n, any positive integer n, can be written as a product of integers from n to 1. So can you not write this as 5 into 4 into 3 into 2 into 1? Right. And then what is this? This is nothing but 5 factorial. So 6 into 5 factorial is nothing but 6 factorial. So we can prove that n plus 1 whole factorial is, that is n plus 1 factorial is nothing but n plus 1 into n factorial. Okay. In using this only, you can clearly say that 0 factorial is 1. You can remember this, but if you substitute n here, what do we get? 0 plus 1 whole factorial is equal to what? 0 plus 1 into 0 factorial, right? So can we not say that 0 plus 1 factorial is nothing but 1 into 0 factorial? So 1 factorial is equal to 1 into 0 factorial, and you know 1 factorial is 1 only. So hence we can say that 0 factorial is 1, and also 1 factorial is also 1. Okay, because product of integers, if you consider 1, then you will get only 1, right? So that's the reason 1 factor is also 1. So these are a few results that you need to keep in mind while doing factorials. Now, how do we tie up factorials with permutations and combinations? Let me ask you a question before we jump on to the discussion. So there are 8 people in a theme park, and we want to make them stand in a queue. They occupy 8 different positions. Okay, so 8 people will stand in 8 different positions. But how many ways, how many possibilities, or how many choices does those 8 people have to stand in a queue? 8 factorial. That means, if for the first blank space, if you say the first person in the queue is standing here, then there are 7 different possibilities, choices to stand in the second position, and then there are 6, there are 5, considering that 1 has already stood here, Second person is stood, third, fourth, 5, 6, 7, 8. So remaining persons are there. 8 people will get a choice to stand in first. Then if one person has occupied this place, then 7 people will get a choice to stand in second position. 6 people in third, 5 people in fourth. 4, 3, 2, 1. So therefore there are 8 factorial ways in which 8 people can stand in a queue. So these 4 choices can be filled in 8 factorial ways. Right. Now, if I say that there are 8 people in a race and I want them to stand in only 4 positions, then how many ways is this possible? Can we say that for the first person there are 8 ways? I mean 8 people can stand in one and we'll choose one person in one place. 7 because one is already occupied in the first place. 6 choices and then 5. So how do we define this? We will write this as 8p4 and here p is a permutation. Okay, permutation is an arrangement of elements chosen from a certain set. Here we have a set containing 8 elements and we want to arrange them in 4 places. That is how we represent this as 8p4. And if you say 8p4 can be written as 8 factorial by 8 minus 4 whole factorial, that is 8 factorial by 4 factorial, we get 8 into 7 into 6 into 5 into 4 factorial by 4 factorial. So in short we'll get 8 into 7 into 6 into 5 only as answer. So this is a permutation. Permutation means, remember there are 2 keywords for you to identify whether an arrangement is a permutation or combination. Permutation means arrangement. Anything that says arrange will get permutation and we take order as a priority. We'll consider order while we are solving the question. Okay, NPR, if you say R is the number of ways and R is the number of objects you need to pick up from a set and N is the elements in the set, then NPR is nothing but N factorial by N minus R whole factorial. Okay, so this is all about permutation. Now what is a combination? In permutation, we have considered order as an important factor. That means order does matter. If I say that ABC is equal to CAB, then this is not a permutation because the order is different. We consider these two as different elements in permutation. So this is permutation. But in combination, we will consider these two as same. Let's consider a set that has 5 elements now. Say for example, we have 5 elements in this set. Okay, so I want to choose 3 elements from this set. Any 3 elements with no concern for order. That means I don't want them to be in order. I don't want you to consider order as an importance here. I just want to choose 3 elements. So for example, if we say A, B, C are 3 elements, how many different ways can these 3 be arranged? Normally in 3 positions, we know that this can be done in 3 factorial ways using permutations, right? So if I say that to take order as important, then how many different possibilities are there for you to arrange 5 elements in 3 positions using permutations? We know that that is denoted by 5p3, right? But here we are saying that we don't want order. We are not concerned about order. That means here we are saying ABC is equal to CAB. For us, these two are still the same. That is where combination comes into picture. We are choosing a set of elements from another set, from the master set. We are choosing some objects from a set. We are selecting some objects from a set, and that selection or choice need not consider order as important. That is where we use combination denoted by C. So if we divide this by 3 factorial, we will get 5C3. That is, we choose 3 objects from a set containing 5 objects. We don't consider order. This 3 factorial, because we'll arrange this, how many different ways can you arrange this? You can say ABC, CAB, BAC, BCA, right? CBA, and then ACB. There are 6 different ways you can arrange ABC. So this is an order, right? We are considering order. We can arrange this in 6 different ways. But if you are considering combination, these all constitute as one element only, because we don't bother about order. So that is the reason if we divide this to the permutation, then we'll get a combination. Combination means selection with no order. That is, we see here is nothing but choose, and we can say this as NCR. Okay, so in short, NCR is equal to n factorial by n minus r whole factorial, because this is the permutation definition, into r factorial is combination. Okay, this is very important for us to know in order to understand binomial theorem. If I say that I want to choose one element from 5, how do I denote that? I will denote that like this, 5C1. And if I say that I want to choose 2 elements from 5, 5C2. 3 elements, 5C3. 4 elements, 5C4. 5 elements, 5C5. So what is 5C1? 5. What is 5C2? 10. That is 5 factorial by 3 factorial into 2 factorial. That we get 5 into 4 into 3 factorial. You can stop it here because 3 into 2 into 1 is 3 factorial into 2 factorial. So we get it as 10. Then 5C3 is also 10. 5C4 is 5. 5C5 is 1. You can calculate the rest. What are these elements? Is there any similarity in the pattern? If you clearly observe, these are the elements of the 5th row of Pascal's triangle. That is the reason I have told you while explaining Pascal's triangle that every binomial coefficient can be determined or represented in the form of NCR. So if you see these are nothing but the elements present in the 5th position of Pascal's triangle. Keeping this concept in mind, now let's derive binomial theorem. Now let's see how to write binomial expansion very easily. So this is the Pascal's triangle I have written for you, and you know that these are the coefficients in the binomial expansion, right? So what is the binomial theorem here? How do we expand a binomial expansion using binomial theorem? For example, I would say the expansion of a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. I have shown you how to write the coefficients using Pascal's triangle last time. So 1, 3, 3, 1. So we put the coefficients as is here. These coefficients can be represented in the form of NCR. We just saw that using combinations, that is, if we select one element from 5 objects, 2 elements from 5 objects, 3 elements from 5 objects, we got the 5th row. For 5 objects, we got the 5th row of Pascal's triangle, right? Now in the same way, there are 3 objects, 3 objects in the set. So that means we need to choose one element from 3 objects, 2 elements from 3 objects, 3 elements from 3 objects, 0 elements from 3 objects, etc. Right? Those are nothing but the coefficients again. So can we not represent 1 as 3C0? Because 3C0's value is 1. In short, NC0 is 1. How? N factorial by n minus 0 whole 0 factorial. If you cancel, you get 1. Because 0 factorial is 1 and n factorial cancel. And can we not say that if you choose one element from 3, it is 3? Because this coefficient is now 3. So can we not write 3C1 as 3? And can we not write TC2 as also 3? Because if we expand in the form of NCR, we will get 3 only. And then if we take 3 elements from 3 objects in the set, then we get it as 1. So these are nothing but the elements in Pascal's triangle? Yes. So in short, can we not write a plus b whole cube as this 3C0, 3C1, 3C2 and 3C3? Yes, and we have plus. So let's put the signs plus here first. Right. Okay. And you know that I told you the powers of the first term will reduce. And here it is 0. Right? And the powers of the second term will increase in then algebraic expansion. For that, can we not say that here 3, can we not represent it as a to the power of, I'll write it clearly, 3C0 into a to the power of 3 minus 0, because we have this as 3, and b to the power of 0, because b is 0 here. 3C1, in the same way, you know that powers will reduce, right? So 3 minus 1, because here we get 3, here it should be 2, 1 and 0. And then b will be 1, because 0 will be increased to 1. Same here, a to the power of 3 minus 2 into b to the power of 2. And then we get a to the power of 3 minus 3 and b to the power of 3. So, in short, is this not this expansion here? Yes, see here. 3C0 into a cube b. 3C0 is 1, a cube. 3C1 into a square b, 3. 3C2 into a b square. 3C3 into b cube. This expansion here is nothing but binomial theorem. See how we got, this is the known expansion for you, and how we have reduced this to this. In short, this is how you represent binomial theorem. You know that till 3 or 4 you are comfortable and you know the values and you can write it using Pascal's triangle also, the expansion. But in place of 3, if we have 25, don't you think, or in place of 3 if we have 10, don't you think this is an easier way to write? Because all we need to do is write the coefficients as incremental form, that is 25C0, 25C1, 25C2 and so on up to 25C25, and then just reduce the power of one term and increase the power of other. It's very easy. That is how we represent binomial theorem. So in short, binomial theorem means for us to expand a plus b whole power of n for positive integer n, then nc0 into a power of n minus 0 b power of 0 plus nc1 into a power of n minus 1 and b power of 1 plus nc2 into a power of n minus 2 and b power of 2 plus nc3 into a power of n minus 3 and b power of 3 and so on up till if you say ncr a power of n minus r into b power of r. Again you can say ncn minus 1 a power of n minus n plus 1 into b power of n minus 1 plus ncn into a power of n minus n and b power of n. This is binomial theorem. If you substitute 3 here, you will see that the expression will stop till here. If you substitute n as 25, the expression will stop at 25. And this is the rth term. That means if you want to find the rth term of the binomial expansion a plus b whole power of 25, r is nothing but if you want to find say 20th term, then what you do is, all you need to do is substitute r as 20 and find. I will tell you all in detail on the terms and the coefficient etc. in my next video. But this is how you will write a binomial theorem. Now if you put all the concepts that I have taught till now together, don't you think this is extremely easy for you to write?